Hi, welcome to Fun with Algorithms. In this video, I'm going to talk about single variable substructure pattern of dynamic programming. And using this pattern, we will try to solve and optimize rod cutting problem. Now, this is the second video of the series on dynamic programming and various patterns of solving dynamic programming. Please do subscribe to receive notifications of new videos in this series. Now let's get right into it. Okay, before looking at this video, it's important to understand basic concepts of dynamic programming. I have already made a video on that topic and I'll put the link to that video in the description down below. If you haven't seen that video, please do check it out before watching this video. Now, this now coming back to this pattern of single variable substructure, it basically means only one thing changes from original problem to sub problem, as the name single variable indicates. Now, the way we memorize this pattern, or the way we tabulate outputs or results of this pattern, is very simple. We can just store the computations in a simple map, or if the key or index, whatever we call it, is an integer, then we can even use array in some situations. Now, how do we actually do this, and how do we analyze if a particular problem belongs to single variable substructure? We will look at that using rod cutting problem. So in rod cutting problem, we will have a rod of length n, and we have a chart of different length to price mappings. So what this chart represents is, so in the given example, if a rod of length 1 is there, then it will be sold for a price of $1. And if a rod is of length 2, then it will be sold for a price of $5. So there is a chart of mapping like this, and we can cut given rod into one of these lengths. Now, given this chart and a rod of some length, arbitrary length n, then our objective is to find the maximum price that we can get for this rod. And not just getting the maximum price, but we also want to know how do we cut this rod to get that maximum price. So say you have a rod of length 14, then you can cut this rod into two pieces, each of length 7, and this is the best cut you can make, as it fetches the best price of $36. You can check it out. You can't make any other way, any other cuts, and get the value which is more than this. Now if the rod is of length 15, it changes completely. Now you had to cut in this way, so one rod of length 7 and four different rods of length 2, and that's the best way you can cut this rod. Now with this cut you can get $38 out of it. So now the objective is to find the best cuts and the maximum value you can get out of a rod of given length and optimize this calculation. Now, one thing to keep in mind is, for any dynamic programming problem, it's better to first approach it to solve it in a brute force method, and then see how we can optimize it, how we can store the results, intermediate results, so that we don't have to recompute every time we encounter the same problem. In my personal opinion, it's better to approach any dynamic programming problem in a recursive way, because there is this optimal substructure, so inherently the problem is recursive. So I will always, in most of the cases, try to solve dynamic programming problems in a recursive way. So I will do the same thing for this rod cutting problem also. But before actually going to optimize it, let's first see what is whether the two main characteristics of dynamic programming problem, that is optimal substructure and overlapping subproblems, will be satisfied by this rod cutting problem. Now again, if you don't know these properties, please do check the video in the link below. I have already explained those concepts. Now coming back to the first property, which is optimal substructure, let's see what happens when we make an initial cut to this rod. So as you have seen in the chart before, there are only four different lengths we can cut any rod into. They are of lengths 7, 3, 2 and 1. Now, so when you start cutting process, you have four options. Either you can cut it into an initial cut of length 7 or 3 or 2 or 1. Now, say if you cut the rod into length 7, so whatever the length remaining, identify recursively what is the maximum price you can get for that length, add it to the price that you get for the rod of length 7, which is $18 in the given example, and that is the maximum value you can get for this rod if you make the initial cut of 7. So that turns out to be $38 because when you make an initial cut of length 7, then the remaining length is 8 because the rod given rod length is 15. And it turns out the best cuts for a rod of length 8 is 4 pieces each of length 2. You can try to do it recursive, you can try to solve it and see that whether it's true or not, because since the length is small, you can actually try to calculate it by hand. Now, if you make an initial cut of length 3, then the maximum value we can get is of 37. Similarly, for length 2 and 1 also we have calculated. And once we check it, we identify that the maximum value we can get for a rod of length 15 is $38, and that we get by making cut at one at length 7, and the remaining rod we cut it into 4 pieces each of length 2. So basically, to get a maximum value, we have to cut it into 5 pieces, out of which one piece is of length 7 and remaining pieces is of length 2. So this is the best way we can cut this rod. So we see that this rod cutting problem exhibits optimal substructure property because we are able to calculate the optimum solution by calculating the optimal solution for its subproblem. Now, to see whether this satisfies the second property, that is overlapping subproblems, let's see a part of the recursion tree when we are trying to solve this problem. So this is just a small part of the recursion tree. There are, if you can go down at multiple to very deep in the recursion tree, but this is enough to prove that this problem exhibits overlapping subproblem property. Now, if you carefully look at this recursion tree, we have actually calculated what is the best value we can get for a rod of length 12 twice. And similarly for a rod of length 13, again we have calculated it twice. That is in a very small portion of this recursion tree. So if you go further down to the entire recursion tree, we might be calculating many more subproblems repeatedly. So from these two things, we know that rod cutting problem exhibits dynamic programming properties, that is overlapping subproblem and optimal substructure. So now comes the question, what exactly is single variable substructure and how do we actually memorize it or tabulate it? So just to define it now, let's take a look at the recursive tree we have here. So the original problem is for a rod of length 15. And if you go one step below that, the only thing that has changed is the length of the rod. So you can see that for the first case, when you make an initial cut of length 7, the remaining length of rod that you want to solve is 8. But rest everything remains the same. The number of ways you can cut, the number of value of the price you get for different cuts, everything remains the same. Only the length of the rod, that is a single property of the problem, changes. So that's what is single variable substructure, and this is the most easiest way of any dynamic programming pattern. Now, coming back to how we actually memorize it, right? So it's very simple. So say you take a map to store these intermediate results, right? So map has key and value, right? Key will be this variable which changes. So in this example that we have here, key is the length of the rod. So that's the only thing that changes. So key is the length of the rod. And what's the value? Value is basically what we want to calculate. So say we want to calculate the maximum value, maximum price we can sell the rod it. So that will be the value. So at each length we store this value, and next time when we need it we just take it. But if you're a manufacturer, you're not just interested in what is the maximum value you can get out of it, right? You also want to know how I should get it. So what is the different cuts that I need to make to this rod to get this maximum value? So that's one more output we are interested in. That is the list of rod lengths that I can cut it into to get the maximum value. So in this case, key of the map will still remain the length of the rod because that's the only variable thing. But now the output is not just the value, it's an array of integers which basically represents different cuts. So in this way, by knowing what is the variable that is changing and what is the output, what is the value we are interested in, we can identify what we are exactly storing. Now we will make more sense of what I was talking about using a program for this rod cutting problem. So I have this code opened here in VS Code. This is rodcutting.go. I have written it in Golang. And if you see from line number 3 to 5, so that is the method the users of this method, users of this rod cutting program call. So you expect length of the rod and different cuts as input, and cuts is basically a map of int to int as the same as chart where we had length as integer and price as integer. Now what we actually return is an integer array which basically says the different number of cuts you have to cut the rod into, and an integer which is the maximum value we can get for this rod. And we create some private method called rod cutting memoized. To this we pass this length and cuts that user has passed. Along with that we pass two empty maps. So this first map is map of int comma int. This is for memoizing the value, maximum value that you can get for a rod. And we pass a second map which is map of int to array of int. And we use this map to memoize the best cut, that is for a given rod, or for a rod of given length, how we can actually cut it to get the maximum value out of it, because these are the two values or outputs that we are interested in. And if you come to rod cutting memoized, it's very simple. So if rod is of length less than or equal to 0, then we just return empty values, because you don't get any value, right, if we don't have a rod at all. And then next step is we actually check whether we have already calculated the price for this length. And if you have already done it, we just return the stored values. If we haven't already calculated, this will be empty. So we just take some default values like max price is equal to 0 and an empty integer array for best cuts. And we loop through all the cuts that the user has given. So that is cut length and cut price. So cut length is basically the length of the rod, and cut price is the corresponding value we can get for that. And if cut length is actually greater than the given length here, that means we can't use it, because if you have a rod of length say 4, you can't cut it into length of 7, right, because that's not even possible. So we just skip that case. If not, we recursively call the same method. So we say that, but now the length changes to length minus cut length, because we already made one cut and we just pass the remaining length to find out its value recursively, and rest all the parameters remain the same. So what this method returns is the best price you can get for that smaller rod length. So that's what we call it as sub price, and the corresponding best cuts, we get it in cuts. Now we add the cut price, that is here, whatever was the rod length that we have cut, with this sub price, and we see if this price we calculated is greater than the max price. If so, we update the max price and corresponding best cuts. And once this for loop completes, we have the maximum price we can get for a rod of this length in the max price, and the corresponding best cuts in this variable. So we just update those two maps first, and then return its value. And this way, we have successfully memoized the output variables for rod cutting problem. So that's all about single variable substructure pattern of solving and optimizing dynamic programming problems. Now, if you like this video, please do like, comment, share and subscribe. And don't forget to press the bell icon to receive notifications on my new videos. See you next week. Thank you.